Hi, I'm Imran. I'm 15 years old. I'm a student in this state senior high school to South Tangerang City, Indonesia. I have special interest in mathematics, physics, and robotics. And I also concerned about environmental problems like plastic waste, especially microplastic. And I believe I can contribute something to overcome this problem. Let's do some research.
Microplastics are those small, often toxic particles that are the result of degrading plastic or consumer products, and even tire wear. There are growing concerns about what their impact could be on respiratory health, as the particles are now being found in people's airways. Many studies have demonstrated how microplastics make their way into our bodies through food and water. However, researchers...
This is a lake near my house. Just like any other lakes, plastics and microplastics are already polluting the water. I think I should design and assemble a robot boat to clean up microplastic from water. A ferrofluid hydro robot. If I could combine Vion Ferreira's ferrofluid method and my robotic skills, I think there is a good chance to build such a hydro robot. Vegetable oil could absorb microplastics in water, and then mix with iron oxide powder. It could form ferrofluids. Then a strong magnet will attract and pull the ferrofluids. But how to construct all that process in a single boat? Today, I'm going to conduct an experiment to clean or extract microplastic from the water using the ferrofluid method. Here are the tools and material. As the microplastic, I'm using the candy wrapper, and I cut them to 1 to 2 millimeters. We need a strong magnet to attract the ferrofluid. I'm using neodymium magnet. These are the strongest rare type of earth magnet. There's this big guy, which is 10,000 Gauss solid type. The ferrofluid is almost all attracted to the magnet. So we continue to the last experiment using the big guy, the rod type of neodymium magnet. The best result, and I also constructed this robot boat with 3 dogs robot arms. 3 dog means 3 degrees of freedom. So it means the robot can move freely to left and right, front and back. The robot arm methods are not suitable to perform this task. The neodymium magnet is too heavy, and its magnetic strength could interfere many electronics parts. So I have come up with a fixed horizontal and vertical axis to control the movements of neodymium magnet. So this is the final model of ferrofluid hydro robot. These are the electronic components, mainly powered by microcontroller MRT5 and also lithium battery 12 volt. How the robot works. So first, the water below this boat will be sucked or intake with this mini pump through this tube all the way to this water container. Assuming the water is polluted by microplastic, the servo motor will pour the vegetable oil, and then the DC motor below the container will spin to steer the oil to make sure that the oil absorb all the microplastic. The other servo motor will pour the ferroxide powder to make the ferrofluid. This magnet will attract all the ferrofluid will go to the other container. And then the DC motor will spin to clean the magnet. After the water is clean, we can pour the clean water back to the lake with the second pump. I will demonstrate how this robot works in my bathtub. The water here is polluted by microplastic. Now the pump is sucking the water in. As you can see, the water is in the water container now, and there is microplastic in there. Here, as you can see, the ferrofluid is formed. You can see the magnet is attracting all the ferrofluid, and the result is the clean water. Pour the water back to the origin. These two big bottles I use to balance the buoyancy of the robot. This ferrofluid hydro robot is my contribution to overcome microplastic problem. Like in the superhero movies saying, with a great mind comes great responsibilities. This is my contribution. What about yours?